Welcome to ScienceCover.com. This session is an introduction to forces, where we will look at scalar and vector quantities, what is meant by a resultant force and how we can calculate it, and how we can use a parallelogram of forces to calculate the resultant force for two forces that are not parallel. First, pause the video and attempt the do now task. Check your answers to the do now task. Let's begin by looking at scalar and vector quantities. In science, there are two types of measurement. The first is a scalar quantity. This measures only the magnitude or size of something. For example, a temperature in degrees Celsius or how much energy something produces in joules. The second type of measurement is a vector quantity. This gives us information on both magnitude or size and direction. For instance, we could measure a velocity as 5 meters per second or minus 3 meters per second. Having the positive or minus symbol tells us which direction the object is heading. Having a force of 3 newtons or minus 2 newtons, again having a positive and negative symbol tells us that these forces are acting in opposite directions. Or we could make a statement about direction, for example 30 degrees from north. This table shows common scalar and vector quantities. The scalar quantities include length, mass, power, volume, the amount of energy, the distance, pressure, speed, area, or work. Vector quantities give us information about direction. So if a speed gives us information about direction, we call it the velocity. If a distance gives us information about direction, we call it displacement. Other vector quantities include force, acceleration, momentum, and weight. Let's look at the difference between distance and displacement. A young girl walks from her home to her school. The school is 1 mile from her home, but a direct route would take her over a muddy field. She therefore chooses to take a path which takes her around the field. If we wish to find the distance that she has travelled, then we ignore direction as it is a scalar quantity. So this path shows us the distance that the girl has walked. And so the total distance that she's covered is 2 miles. However, if we wish to find the displacement of the girl, we're only focused on the direction that she's travelled. So we look at her starting point and her end point, and we mark the distance from the start point to the end point and the direction. So we could say that she's travelled 1 mile southeast. Pause the video now and attempt task 1. Let's check the answers to task 1. What is the difference between a scalar quantity and a vector quantity? A scalar quantity only gives information about magnitude or size, whereas a vector quantity gives information about magnitude and direction. Place the values in the correct columns in the table. So the scalar quantities are length, power, volume, mass, area, work, speed, energy, distance, and pressure. The vector quantities are force, acceleration, weight, velocity, displacement and momentum. Little Red Riding Hood lives 2 kilometers from her grandmother. She uses the indirect forest path, walking 3 kilometers to get to her grandmother's house. This takes her 0.5 hours. What is the distance walked by Little Red Riding Hood? So we can see on the diagram that the path is marked as 3 kilometers long. So the distance that she walks is 3 kilometers. What is the displacement of Little Red Riding Hood? Well, the house is 2 kilometers away from her start point, so her displacement is 2 kilometers. What is the speed travelled by Little Red Riding Hood? Well, speed is a scalar quantity, so we'll use distance and time. So that is 3 divided by 0.5, which equals 6 meters per second. Whereas velocity is a vector quantity, so we'll use displacement divided by time. So that's 2 divided by 0.6, which equals 4 meters per second. Now let's move on to look at what we mean by a resultant force. Resultant force is the overall force acting on an object. So here we have a baseball, and it has a 5 Newton force and a 7 Newton force. The resultant force is the combination of these two forces. As they are in the same direction, we should add them together. So 5 newtons and 7 newtons gives me 12 newtons. So the resultant force is 12 newtons to the right. In this example, we have a baseball with a 5 Newton force and a 4 Newton force acting on it. And these forces are acting in opposite directions. So I'm going to call the force to the right a positive value, 5 newtons, and I'm going to call the force to the left a negative value, minus 4 newtons. Now when I add these two together, 5 plus minus 4 gives me 5 minus 4. So that equals 1 newton to the right. So this value of 1 newton is positive, so it's telling me that the ball is moving to the right. In this example, we have a 12 Newton thrust force from the bike, 3 newtons acting as friction from the wheel, and then 4 newtons acting as air resistance. Now, since we can assume the bike wants to move forward, then we'll call the value to the right the positive number, so that's 12 newtons. And then the forces that are acting in the opposite direction, I'm going to give negative values. So I'm going to call the friction minus 3 and the air resistance minus 4. So now when I add all these three values together, 12 plus minus 3 plus minus 4. That's like saying 12 minus 3 plus 4. And that gives me 5 newtons. Now again, the 5 is a positive value. So this tells me that the overall force is acting to the right. In this example, we have a truck with a 10 Newton thrust, 3 Newton frictional force, and 8 newtons of air resistance. Now, as the truck is moving forward, we'll call the value of 10 newtons a positive number, and we'll refer to the resistive forces, the 8 newtons and the 3 newtons, as the negative values. So we're going to call them minus 3 newtons and minus 8 newtons. Now if I add these three values together, 10 plus minus 8 plus minus 3 is like saying 10 minus 8 minus 3, which gives me minus 1 newton. Now by being a negative value, this tells me that the larger force is acting towards the resistive forces, and that means that this truck is going to be slowing down. Oh, for fuck's Pause the video now and attempt task 2. Let's check the answers to task 2. Number 1. Calculate the resultant force of each of the following situations. So we have a 7 Newton and 5 Newton force acting in the same direction. So the resultant force is 12 newtons. When we have a 5 Newton and 2 Newton force acting in opposite directions, we do 5 take away 2 is 3 newtons. We have a motorbike with 20 newtons forward and 4 newtons backwards. So we can do 20 minus 4 is 16 newtons. And in D, we've got a 5 Newton force forward, 4 newtons and 4 newtons acting backwards, that's 8 newtons. So 5 minus 4 equals minus 3 newtons. Describe if the truck is accelerating, decelerating, or travelling at a constant speed. So in A, the truck is accelerating, in B, the truck is decelerating, and in C, the truck is at a constant speed. Now let's look at how we can use a parallelogram of forces. Until now, all the forces that we've looked at have been in the same plane. But how do we work out the resultant if we have more than one plane? Let's work out the resultant force on this baseball. First, work out the resultant of any forces that are in the same plane. So we have a 5 Newton and 4 Newton force acting in the same plane. So we can do 5 minus 4, which gives us a 1 Newton force to the right. Now we can use our forces to draw a parallelogram of forces. To do this, pick a start point on a piece of paper. Draw the lines to scale on the sheet of paper. So we have a 3 Newton force down, so I'm going to draw a 3 centimeter line down, and a 1 Newton force to the right, so we can draw a 1 centimeter line to the right. Now turn the shape into a parallelogram. To do this, mirror the lines we've drawn on the opposite sides of the shape. So I'll draw a 3 centimeter line down on the right and a 1 centimeter line across the bottom. Now the resultant force runs from the start point to the opposite side of the diagram. What we need to do is to measure the length of this line. So using a ruler, I can measure that length, and it's 3.16 centimeters. Now since we've been working to the scale of 1 centimeter equals 1 Newton, I know that the resultant force is 3.16 newtons. In this example, a man is sinking in a kayak. He uses his oar to create some diagonal force at an angle of 20 degrees to the horizontal. What is the resultant force? The first rule was to work out the resultant of any forces in the same plane. In this particular example, there are no forces in the same plane. We have two forces, a 3 Newton force and a 10 Newton force, and they act in different directions. Let's pick our start point. But first, we've represented the 3 Newton force as a 3 centimeter line vertically down. Next, we have a 10 Newton force at 20 degrees to the horizontal. We can represent this as a 10 centimeter line drawn at 20 degrees to the horizontal. Next, we need to turn the shape into a parallelogram. To do this, we mirror the lines we've already drawn. The resultant force runs from the start point to the opposite side of the parallelogram. That's represented by this line. If we measure that length with a ruler, we discover that it's 9.4 centimeters. But since we use the scale of 1 Newton to 1 centimeter, that means that the resultant force is 9.4 newtons. Pause the video now and complete task 3. Let's check our answers to task 3. Use the parallelogram of forces method to find the resultant force acting on the ball. For question 1, we should have had 5 newtons. For 2a, we should find 6.3 newtons. For b, the resultant was 4.24 newtons. For c, we should find the resultant as 3.6 newtons. And for d, we should find the resultant is 12.1 newtons.